All right, so today is the 8th installment of the POODR book club. We're doing Chapter 8, Combining Objects with Composition. I'm Mary-Katherine McKenzie. I'm relatively new to coding, but really liking Ruby so far. Clayton, do you want to introduce yourself?
Hi, I'm Clayton. I'm a Ruby dev, and I guess that's it.
Nice. Mo, do you want to introduce yourself?
Yeah, my name is Mohammed, and I'm a Ruby newbie. I've been coding in Ruby since April this year.
Cool. All right, so we're I've been coding Ruby since like May, or March, so we're like right there. All right, so I'm gonna start the screen share. Screen share, entire screen.
Share and tap yourself.
Oh yeah.
I'm also hearing myself on your speakers.
Oh really?
Mm-hmm.
Let me grab my headphones real quick.
I can't remember if I told you that I got feedback from RubyConf about when they're going to be doing the birds of a feather stuff.
Oh yeah?
Yeah, it's going to be, I think they said it would be on Saturday and Sunday? I don't remember. I have it. I have the tweet. I'll look at it later. But they said it would be where they're having lunch.
Oh cool. Cool.
And it'd be like in the afternoons, I think.
Okay, so we should
try to schedule one on one of the 2 days they're doing it.
Yeah. How do we get the
We actually do it while we're at RubyConf.
Okay.
So
neat.
Yeah. You just put it up on a board that you want to organize it and go from there.
Cool. So I guess for anybody who's listening later, come and going to RubyConf, come join us at our POODR Birds of a Feather session. So that'll be fun. Also open to non-book club members, since it would literally just be the two of us.
Oh, I know some people I think that'll be there.
Yeah, that'll be awesome. So, okay, Chapter 8, Combining Objects with Composition. So this chapter was a lot for me.
This feels like 2 chapters, actually. Like
yeah, it does.
Is just like the last 2 chapters where it covers like a new thing, and then the last half feels like its own chapter where it's like how to decide between the 3 things we just learned.
Right, which I feel like would have been like the perfect subject. Like the second half definitely should have been in PowerPoint form.
It should have been its own chapter too.
Yeah, probably. Yeah, I do like how she lays it out. In the back half, how it's like, here are the pros, here are the cons, here's how you decide.
Yeah, it was really good.
Yeah, it was very clear. Not a lot of steps clear like that. So I don't actually have a summary slide, but I'm going to read just a couple of sentences of the summary for those who haven't read it. So composition, this is on page 190, the very last page of the chapter. It's composition allows you to combine small parts to create more complex objects, such that the whole becomes more than the sum of its parts. Composition, classical inheritance, and behavior sharing via modules are competing techniques for arranging code. Learning to use them properly is a matter of experience and judgment, and one of the best ways to gain experience is to learn from your own mistakes. So that's kind of what this chapter is about. So here I just defined composition, but here it is again. It's also on page 163 is where the chapter starts. So she talks about the larger whole being connected to its parts via a has-a relationship, which is different than inheritance, which behaves like a and is a.
Right.
So I think, modules behaves like a. in classical inheritance is
Correct.
yeah.
Right.
So jumping off from that, now this is a has-a relationship, and we'll be building on the bicycle analogy that we talked about in chapter 7. So basically refactoring all of that code again until it completely replaces the inheritance. So now we have the bicycle class right now is just like an abstract superclass in a hierarchy. So we have bicycle as being like the top superclass, and then I think it's like mountain bike and road bike are subclasses of bicycle, and I don't know if it gets any further than that. I forgot already.
No, she doesn't even go into the subclasses. It's all refactoring on the bicycle superclass.
That's right. And then for the modules, we kind of get into like schedule and schedulable and etc. So now we need to rethink how to maybe restructure this bicycle class, because maybe inheritance isn't the best way it should be structured. So naturally, bicycles are composed of parts, and I thought that was, it's a great analogy because, a gear is a gear in of itself, and a pedal is, and a wheel all work kind of independently, but together they create a bike, which is something more than each of the parts' abilities. So now we have this new class, parts, which holds a list of the bike's parts. Also, parts knows which of these parts needs spares. And parts is a collection of parts, which just saying it out loud doesn't make any sense.
Yeah, she actually kind of touches on the hinkiness of that later.
Yeah. It does get a little confusing if you're not looking at the text because of capitalization.
Yeah, the parts class is just a collection of bicycle parts.
Mm-hmm. So, so the bicycle class here in figure 8.1, we've got, it sends the spares message to the parts object. And that's kind of what we just talked about, sort of. So, and then the next part illustrates a has-a relationship wherein the bicycle has a parts, and I think my computer auto-corrected that to have a.
Yeah.
So, because it's supposed to be has-a.
Right.
It's just not great for code. So, and it just has one parts class per bicycle class. So now here we're updating, we're just writing code that reflects that, adding the parts variable to hold the parts object. So now we have the bicycle has 3 responsibilities: knowing its size, holding onto its parts, and answering to spares. And okay, so one thing that kind of I got held up on, I think, was just this size notion, because we talk about size in the sense of bicycle, I guess, just like small, medium, and large, but then later she talks about size in the sense of arrays and how you can't call size on certain things because you won't get the right thing back. And I'm not really sure. I don't know. I just got confused there.
Yeah.
I don't think it's referring to the same thing. I mean, it's not referring to the same thing, but it's just like.
Let me look at it real quick. So, yeah, so that's one of the things she dealt with is like, so right now you want the bike to be small. When you call size on the bike, you want it to return small, medium, or large.
Mm-hmm.
And because those are like the 3 categories of bike sizes they have available for customers or whatever. But if you do the wrong kind of refactoring, because she went down one road, she's like, well, we could refactor it doing this, but if you do that certain way that she did the refactoring and you call dot size on a bike, it's actually going to count the size of an array of parts, and that gives you the wrong kind of expected result.
Right. So is that do you think that's a matter of like just bad naming? Like would it be better to name that knowing that, I mean, I don't know how else you would name it.
No, I don't either. I think she's just pointing out that like she gives options for potential refactoring, and she shows why that one might be problematic.
Right. Okay.
Yeah.
I think in the first example, she calls size, the size message on the bicycle object, but on your other example, she calls it the size on the parts array.
Right.
Mm-hmm.
Yeah. They
So
both
totally different objects in this case.
Yeah.
Okay. Right. Yeah.
And so since parts, the size of your parts, it makes sense for it to return a number because it has a number of actual part pieces.
Yeah.
So it has like the parts class is a collection of parts. So when you call size on my collection, it makes sense for it to return a number, but you don't want it to return a number when you do bicycle. You want it to return small, medium, or large.
Mm-hmm.
She's just pointing out that that's an example where you can, well, and actually, yeah, the refactoring that she did was actually on the parts class, not on the bicycle class.
I think also there is an alias for arrays, which is count. So it might have been better to call count instead of size on the parts array.
Yes, that's true. Though I don't know if that alias was there whenever she wrote this book.
Yeah.
There's no telling.
Yeah, so now we've got this bicycle class here. And we're going to create a parts hierarchy. So we take the code that we cut out of bicycle and just put it in parts, and it's almost exactly the same. And sorry for the awful formatting, but it's on pages 165 to 167. And this is all the stuff that was, I mean, it's literally just copied and pasted, except for the classes were renamed and the size variable removed, because now that's in bicycle. So here we kind of have a graphical representation of the code that we just looked at. So bicycle has one parts object, and mountain bike parts and road bike parts are both, I guess.
Inherit. Yeah, it would have a classical inheritance.
Right, okay, so yeah, they inherit from parts.
Yeah, parts, right.
So, and then we go through and she shows how it works and how it's not really a huge improvement or a change, because I mean it does the same thing, but it didn't change a whole lot. But from this we can now tell that bicycle didn't have that much specific code to begin with. You know, maybe it shouldn't have been such a big class before.
Right. So the improvement is that it makes bike only have one responsibility, and it moves the different responsibilities out into new classes and makes all the classes all have a single responsibility.
Right.
Exactly. So she uses all the techniques since chapter 2, I guess.
Right.
Yeah. Which is crazy. It's all coming together. But so this is just showing that it still works. So this is what we kind of touched on earlier, composing the parts object using plurals for names, saying a parts object that contains many part objects,
right.
Which is kind of a tongue twister. And she kind of goes into
I've run into this in my code before, and it's pretty obvious if you like it works out okay.
Right.
Yeah.
Yeah, but I definitely do appreciate how she explains it, because if you're just kind of like skimming over it, you're not going to catch that necessarily.
Right.
That those are different things. But yeah, she gets into saying, you know, you refer to it as an object and then pluralize the object instead of the object name, like we do here with parts object versus part objects, as a way to avoid confusion. So here we are in 8.4, adding the new part object. 8.5 shows that parts can have multiple part objects. Because it says one dot dot over
So
there.
one-to-many relationship.
Mm-hmm.
Yeah. One parts list can have many parts.
Right. But bicycle can only have one parts object.
Right. You have a one-to-one between bicycle and parts and a one-to-many between parts and parts.
Right. So here is the now updated code to reflect the figure. Let's see. So I guess we just have, now we have this parts class, and it has spares, and that's the only thing that it's responsible for.
Mm-hmm.
And then we also have part, which is right now just an initialize method. So pretty short.
So yeah, actually the parts list gets each like an array of parts objects will get passed into the parts list.
Mm-hmm.
The parts object. An array of part objects will get passed into the parts object when it's built, and then when it calls spares, it just uses some logic to get all of the things that need spares and return them.
Mm-hmm. So, and then I think, so this is where I kind of dropped off with the PowerPoint. It was a really dense chapter. So I'm just going to, I have all the pictures here in chapter 8 because I'm super organized. And somewhere I have, that's what we just looked at. That's not the new one. Okay, so can you guys see that?
Yeah.
That kind of makes sense.
So
yeah.
So there's some things that she up to this point that she hasn't implemented that she wanted to have. So she wanted to have, whenever you call spares, it returns
An array of parts.
An array of parts that need spares.
Yes.
But you can't. But she wants it to act more like an array. So she wants things like it to have like parts dot size. And right now that's not implemented. And so you could do. Let's see. She goes through several ways of doing that. You can fix the proximate problem by adding a size method to parts. You could. She doesn't like that because it creates because you're going to have more and more things that you might want to. You're going to have more and more things you might want it to do that becomes that to make it act like an array. And eventually you get around to where you're actually, she actually has parts inherit from array just to see what happens. And when she does that, it creates a mess because whenever you, let's see, what was the thing that it breaks? It's on page 174. Some of the methods in array, when you call them, return new arrays, and whenever that happens, you're actually you no longer have the parts class. You have an array class.
Mm-hmm.
And so it doesn't have all of the other methods that you want for parts anymore. like spares. Spares goes away. So you don't want to inherit from array because some of the methods will destroy the methods that you want to have, essentially.
Yeah. So it's very clear at when she creates the combo parts in page 174, which are basically two parts collections. And
Right.
when she uses the plus to concatenate them, it turns into an array, as you said, and then it breaks. So you
Right.
can't actually call
Spares
on that. Yeah.
Yeah, and she shows at the bottom, it says mountainbike.parts.class is a parts class. Roadbike.parts.class is a parts class. But combo parts, when you concatenate them together, it returns an array because that method in array creates a new array. And then you lose everything that's defined in the subclass of parts. So that's not a good way to go. And then the next page she uses forwardable, which is not something I'm super familiar with.
Yeah, I don't know about that either.
I think it's kind of like a module inheritance, isn't it?
It's kind of separating responsibility and delegating a certain function call to the array, but keeping all the other properties to itself. So it's as if you're delegating a job to somebody, telling him go do this specific task, but still doing the other important tasks yourself.
So that way you wouldn't lose spares.
Exactly.
Yeah, but then you get the cool stuff like she can include enumerable in it. Then you get all of you can do all of the things to the parts list that you would be able to do with an enumerable.
Yes, like
call each and stuff like that on it.
I think each was delegated to the array. Enumerable is used for something else, which is which one is that?
I'm looking it up right now. You may lose me for a second. My computer's trying to freeze up. No, there it goes.
The only hint she gives is that it includes enumerable to get common traversal and searching methods. So
you get a bunch of methods with each, or with enumerable. You get all, collect, count.
Yes.
Each with index, that kind of stuff.
Yeah, so she also says now parts now responds to size, each, and all of enumerable, and obligingly raises errors when you mistakenly treat it like an actual array. So it's like you can dance around it as an array, but it's not going to work as an array. So
I'm pretty sure each is not actually part of the enumerable method module, but I think that anything that has enumerable you can call each on, because I think each is actually, I think the enumerable module implements each, like on a lot of its methods.
I think the array actually is an enumerable type, and array itself is an enumerable type.
Yes.
So it's a little bit confusing knowing which is which or which does what, but the point here, I'm guessing, is she's using the forwardable to forward or delegate some functionality to the array class. She's including enumerable to also use some enumerable properties for traversal of the parts collection, and still keeping the spares function to return all the parts that need a spare.
Right. So let's see. I think we the next part is where she talks about she tries it out, this new parts class, and it works. Both things return size. This is the beginning of it. Mountain bike equals, yeah. So this is, you set the size, set the parts, and it ends up working if I can find the correct thing.
Yeah, page 176.
Array does inherit from an enumerable.
Why aren't these pictures in order?
What, we're on 176, you said?
Yes, 176.
Yeah.
Yeah.
Top of page 176.
So I liked the way she created like a, like she assigned like a parts list to each of these variables, and then you just pass the variable in when you want to build a new part.
Yeah.
Or like a configuration list. Because I could see myself doing something like that, where you have like a file system where you have like you know, road config file that just reads in. You pass the you know, you just use IO to pass in the contents of that file into a new object, and then build the object from whatever's in that file.
Yeah, true. It refactors the code and simplifies how you basically write your functions, and
it also kind of separates the data and the logic from one another a little bit.
Yeah, which we're gonna get to, I think, by the next section. Maybe not yet, maybe later on.
Yeah, so now, yeah, we've talked about the config.
Yeah.
So then she gets into this concept of a factory, which she said this before. She's like very much saying don't be annoyed that it's called factory. It's just a word. It doesn't mean
it. You were there. You were just there.
This is it?
No. No, the one before.
This is it.
Oh, no, that's a later one. That's a later one, yeah.
There we go. Okay. Right? Yes. Okay. So yeah, she basically talks about not discriminating. It's the word factory. It's just a word. Don't worry about it. But she basically just says its job is to take an array like one of those listed above and manufacture a parts object.
A factory is a very famous design pattern, and it's very simple as well, because when you create any class, you have the initialize method, which is responsible for actually instantiating an instance object of that class. So factory, what it does is when you have a collection of things that you want to instantiate at once, then you separate that responsibility to a factory. Sorry, I'm blanking out. A factory class or a factory method. So it's actually responsible for doing all that creation of collections.
I've actually run into, like, I have code that I want to go back, like in production. I have code in production that I want to go back and use this on, because it would actually improve some of the code that I've written in the past. I have some code that builds legislators from JSON, and it always it builds a group of legislators, and this would be perfect for that, this style.
Yeah.
One more point I think worth mentioning. Sometimes at runtime, when your program is actually running, you don't know at which point you're going to create a mountain bike or you're going to create a simple bike. So a factory also can hold the logic to decide at a program runtime which object to instantiate or which type of bicycle to instantiate. So it also makes sense that a factory not only just blindly instantiates object, but also decides at runtime the logic of which object should be, which object type should be created.
So I'm talking right on the very edge of my knowledge here, but is that the kind of situation where you might use a lazy
Uh, um, I get you. What you mean? Lazy instantiation.
Yes.
Uh,
When you don't know when it's going to be, like, you don't know when it's going to be needed, so you like set it up with a lazy instantiation, and then it only uses it if it needs it.
Lazy, I think when you say lazy instantiation, you're talking about when rather than
Okay.
what, right?
Okay.
A
I'm not
factory,
sure. That's what I'm saying. I'm talking right on the edge of my knowledge.
yeah, me too. I'm not really an expert in factories, but factories deal more with what type of object you want to instantiate, but lazy instantiation is when.
Okay. Okay. That makes sense.
Well, I think you can mix and match. So you can actually make a lazy factory if you like, making the instantiation become later on after you decide many types of many objects. Then you can run your factory.
Okay. I need to look at that more. But sorry, it's a derailing. It just when you started talking about waiting until runtime or whatever, that piqued that kicked that idea off in my head.
Mm-hmm.
Yeah. So yeah, I think this is just showing this in action. So yeah, so you're basically just taking those config arrays and building information
Parts.
out of them. Yeah.
Building a parts factory. Yeah, building a parts factory.
So I guess it's
or like a parts list. Building a parts list. Yeah.
Right. Okay. So she says parts factory combined with the new configuration arrays isolates all the knowledge needed to create a valid parts. This information was previously dispersed throughout the application, but now it is contained in this one class and these two arrays. So that's exciting. So the next part is leveraging the parts factory. And this is where she gets into OpenStruct, which is completely over my head. So
we talked about struct some earlier in the book.
Yeah, I remember that, but it's still like very vague just because I haven't had a chance to use it. So it's like, when you haven't, it's like not cemented.
It's
Mohammed,
yeah.
Go ahead.
It's basically not very complicated to understand data structures basically. And I quote forgot his name. Uncle Bob, Bob Martin. Data structures are just objects that have data with no methods. Unlike classes, where they are a combination of data and methods, structs, open structs, and data structures in general are just the data.
Okay, gotcha.
And
so
go ahead.
I was just wondering, so you just use it to house data and you don't actually call anything on it?
You can call it creates methods that just return the data. So it creates like a name method and a description method and a need spare method, and returns those. But it doesn't create create like a you don't have like a any logic built on like you don't have a bunch of methods that built on top of that have a bunch of logic in them. It's just returning data.
Okay.
You can imagine a class with some attributes, and you only have an attr accessor or an attr reader, and that's it.
Okay. So I think if I can find it, it's
essentially what she had with the parts factory, except that it just it does the same thing the parts factory did basically. It just
Okay, I see. So yeah, I think the first time I read through this, I definitely missed the fact that Parts Factory is now a module.
Right.
Has it always been a module?
Yes.
Yeah, it is. I think.
Okay, so I missed that completely.
And this also goes back to the past chapter, which I haven't read. So now you can make any object you want. You can make it factorable if you wish.
Right.
Okay.
So I actually got on Twitter and was asking around about OpenStruct because I'd only knew about Struct. I didn't know anything about OpenStruct. And some of the people on Twitter were talking about some of the strengths and weaknesses of it.
Mm-hmm.
So it's great for it's basically it's like one good use is this kind of situation where you're having a factory and you're building data structures from it like this. But if you're running an older version of Ruby, it's pretty slow. So that's not the more recent versions of Ruby. It's sped up considerably, but it's pretty slow in older versions of Ruby. And it also because it has an accessor and a reader, you can call if you have a spelling error. It'll instead of returning a method missing, it'll return nil, which could be something you might not want.
Yeah, could be misunderstood for the data is not there.
Right.
Or yeah.
So it's not ever going to throw a method missing, which is what you want a lot of the time. You don't want like hidden nils. You'd rather have Ruby has a bad habit of throwing nils when you want method missing. In this case, or with an OStruct, you're going to get that.
Interesting.
It acts kind of like a hash in that way. It's basically, so my understanding of OStruct is basically it's a hash that also the keys can be used as dot methods.
Yeah, correct.
Oh, okay.
So, I'm not really sure on this, but I think the dot methods are an alias for the double brackets array as well. So just aliases to that.
So when you call a hash, you use brackets to call the key. This lets you, instead of having to use brackets, you can just call dot the key, and it'll work.
Okay. I see what you're saying now.
Yeah. Which might confuse some to think that this data structure actually has methods when it actually doesn't.
Yeah, it acts. It's basically a hash that has dot methods, but it's not. They're not actual methods. They don't do logic. They just return. They just act like a hash. They just return the value for the key. Except like a hash, it's not going to throw a method missing when you call a method that's actually missing. It's going to throw nil like a hash would, which can be dangerous.
Right.
Also, as a rule of thumb, I think just going on and using OpenStruct would be much better than using plain old struct. For two reasons. Metz mentioned one in the book. I'm not sure which version of Ruby she used when she published this book. But right now there are two differences. The first being that the OpenStruct uses a hash instead of plain old attributes, and also OpenStruct you don't have to know all the values or construct all the values of your attributes at the time of initialization of this OpenStruct. So later on you can add more or remove even.
Yeah.
But struct doesn't do that by default.
Right. Struct will, yeah, that's right. Yeah, that's the whole point of OpenStruct, is that it doesn't, it's open to getting new things later.
Absolutely, yeah, correct.
Okay. Got it. That makes a lot more sense. Also, this is totally a side note, not related. Who tweeted out that article about this guy whose last name is Null?
Oh, that was me.
Yeah, that was really, that was a great article. I just like never. Yeah, it was, yeah, because you were talking about
It was on
the
Wired,
match
yeah.
case, yeah.
So
Yeah.
is it like nil or null or?
No, it's Null.
Null.
His last name is Null, and he basically breaks databases every time, all over the place. And so, like like Bank of America can't bill him because when they try to automatically generate his billing statements, it doesn't work.
It just says Mr.
Yeah. Yeah. So that was actually like, yeah, that's why I tweeted about it. I was like, I wonder what this would do on my like Postgres, because I use Postgres in my database. I'm like, I wonder what that would do if somebody with a last name signed up. And then I realized, well, I'm not actually saving their last name to my database, so it should be okay. But like Bank of America, he used null at, and he also had named his company after his last name, so he has like null at nullsomething.com, yeah. And so when he used the name null, it broke for a while, and then he switched to using a different username at the company name, and when they updated their system, it actually made it worse, and it quit taking his username or his email.
Oh man,
just crazy.
Or his website name. I mean, yeah.
Yeah, and somebody accused him of trying to hack their database, and he was just like, nope, that's just my name.
Yeah. Yeah.
So watch out for that in your edge cases.
Account for people with the last name Null.
Which.
But then if you think about it, it's technically it's not the fault of the database. In this case, it's the fault of the application, or rather the guy who wrote the application.
Right.
Right. Well, that's what the article was about, was like, this is a problem for me. People need to be aware of it when they're writing new systems.
Uh-huh.
So yeah, it was like one of those like epiphany moments where, like, as soon as I saw the headline, I went, oh God, that would be awful. That's terrible. I have to read this whole article.
Right. And it's great because he's like a tech guy himself, sort of.
Yeah. He was a tech journalist, wasn't he? Because he talked about people accusing him of using an alias to to get like nerd cred, and he's like, no, that's really my last name.
What are the odds?
Yeah.
Anyway, so that's a fun side note.
The article is on Wired, and it's pretty obvious when you see it. It's something about Null being his name and why he breaks computers.
Yeah.
Or is invisible to computers or something.
That's great. That's gonna be the worst when everybody, like, everything is digital and like there's no like physical birth certificates.
Well, what happens when people who know start like trolling by naming their kids like I wouldn't do it, but I know people who might troll by naming their kids, like, you know. Well, there's always the whole Bobby drop tables thing.
Right.
The old XKCD joke.
Right. Yeah, that's. I can see somebody doing that. I mean, people have named their kids weirder things.
Yeah.
But something to be aware of going forward.
Yeah.
So back to bicycles.
Sorry.
Let's see. What? Yeah, I completely derailed us there, so I apologize. But I thought it was fun. So let's see. Okay, so this is the next, I guess, building from since we constructed the parts factory module with OpenStruct now. This is us running it after we've established that. So as shown below, it returns a parts that contains an array of OpenStruct objects, each of which plays the part role.
So I don't think she mentions it here, but this solves the problem that she was talking about in the earlier chapter where you have like recumbent mountain bikes, because you just have a separate configuration for recumbent mountain bikes.
Mm-hmm.
And that like it like naturally fixes that problem. You see what I'm saying?
Mm-hmm.
Because right here, you have a recumbent config, you have a mountain config, you just have a recumbent mountain config, and that works the same as any other configuration. You could infinitely add new kinds of configurations without breaking anything.
Yes, true.
Because you don't have inheritance. You don't have an inheritance hierarchy that cares about configuration.
Yes.
Yeah.
So yeah, so you it's the open-closed principle, I guess. Or did she speak about that? Yeah, it's
Yeah.
open for extension but closed for modification. So you
Right.
can keep adding new types of parts, but still never touch the actual logic of bicycle or parts.
Yeah, and classical inheritance had that problem
Yeah.
because it shared data and logic. There were times when if you messed with the data, it made it really difficult to make the logic work
Yes.
because of certain configurations. Because you needed to inherit logic from two different classes, and it created new problems.
Yes, but in this case, we are actually extending. What are we extending logic? We're extending. We're,
She's extending, and this she includes enumerable and extends forwardable, but that's only in the bicycle class.
mhm.
I still don't have a good firm grasp on what forwardable does.
Yeah, I don't at all either.
She mentions it earlier, but I don't have a good grasp on it.
Yeah, I don't either.
So imagine I tell you, for example, Clayton, this is our software requirement, and this is the requirement that you are responsible for building. And
Okay.
then you, having your own team of developers, then you forward this task to some of your sub-developers. So it's a matter of just forwarding messages, or
Okay.
AKA delegation.
Oh, okay. So, I see in here where it says if you extend forwardable, then she has delegators too.
Yes, so underneath that line in page 175, so she's extending forwardable, and then on line 3, and then on line 4, she's defining the delegators. So she's defining a delegator on the parts collection, which is part of the parts class, and she's delegating exactly two methods, the size and the each.
So you could call size and call each on the parts class.
Yes.
I see. And she's extending that from enumerable.
From forwardable.
From forwardable. Okay, all right. And then she also includes enumerable there, so that. So when you extend, do you also always include?
I'm not sure about that. There is a distinction, but I'm not really sure.
Okay, maybe somebody will come in and talk to us about that. I need to go read some blog posts on forwardable. Seems like it could be useful.
Yeah, so let's see. So the next part we talk about the composed bicycle. So now it's the bike as a composed, now that it uses composition as opposed to hierarchy. And we are going, that's the second part of it. Is this it? Yes, okay, so this is the first part of it, where we have the spares method, and that's kind of it within the bicycle class itself, and then parts and forwardable. And now we have spares within the parts class, and our parts factory, and then our config arrays at the bottom. So this is a lot less. It feels like less stuff than the last one, the one with the hierarchy. So,
she's got three things here. She has the bicycle class, which is real simple. She has the parts class, which is a collection of parts, and it has a lot of the stuff that an array has, including each and size, and then all of the enumerables. And it has a spares, and then she has a parts factory module, which inside of it, if you notice inside of the parts factory, it actually, when you call create part, it actually instantiates an open struct.
Yes.
So the module itself isn't, because you can't initialize a module, but you can when you use it. She's initializing. She's building an array and initializing open struct on each one of the components of the array. Or well, I don't know if it's an array, but no, it's just an open struct. She's using the factory to spit out parts, and then she has the configurations, the road config and mountain config and road bike. Oh, okay, and then we go to 182. So if you go to the next one.
Mm-hmm.
So it starts with road bike.
Oh, here we go. Yeah.
So this is where she actually builds it. Road bike equals bicycle.new, and it has a size, which is large, and a parts, which is just a parts factory.build road config. So it has everything there you need for a road bike. It's got a bicycle class, a size, and a parts. And the parts is actually an array built from the factory, an array of the road configuration.
Right. Yeah, that was
an array built using the road configuration.
Right.
And then you can call roadbike.spares, and it gives you an array of all of the things that need spares. So when you call, it calls need spares on each one of the things in the array, and all of them that return true, it returns an array of that. Mm-hmm. And then mountain bike does the exact same thing, except it just uses the mountain config. That's the only code difference in the actual implementation.
So yeah, and then she also talks about now it's really easy to make a new bike because all you have to do is
change the configuration.
Yeah, and then make a new bike.
Yeah, so she does recumbent. She doesn't show off recumbent mountain bikes, but it would be super easy to do that just as well.
Yeah. So yeah, here we go with the last bit and the new bit. So she tops it off by saying you can now create a new bike by simply describing its parts, which is pretty cool.
Mm-hmm.
And so the rest of the chapter doesn't have any neat pictures with it, but so I'm scrambling anymore. But the next part,
this is where the next chapter begins.
Right, essentially. Yeah.
As soon as she gets past the aggregation digression, the next chapter begins. What feels like it should be a whole new chapter begins.
Right. So, yeah, she has kind of an aside for aggregation, saying it's a special kind of composition.
I read it and it didn't seem like it was super important, so I just kind of read it and went, okay, that's interesting. If I ever need to know that again, I'll go look it up.
All right. Yeah. So I think she just says, like, what it ends up being is, like, the example that she gives that is like a university Universities have departments, which in turn have professors. If your application manages many universities and knows about thousands of professors, it's quite reasonable to expect that although a department completely disappears when its university goes defunct, its professors continue to exist. The university-department relationship is one of composition, and the department-professor relationship is aggregation. So that kind of sums it up pretty well, I think.
Yeah, she just says composition gets used two different ways, and in one of the contexts, aggregation is the thing it's compared against.
So now we start kind of the second section of this book, deciding between inheritance and composition. Which, yeah, it does feel like it should be a different chapter, for sure. So she talks about classical inheritance as a code arrangement technique. That for the cost of arranging objects in a hierarchy, you get message delegation for free, and composition reverses those costs and benefits. So it allows objects to have structural independence, but at the cost of explicit message delegation.
So I thought the most useful analogy she gave for the distinction between the three is that for classical inheritance, it's an is-a relationship. For module inheritance, it's a behaves-as relationship. I think that's what she said. And then for composition, it is a has-a relationship. Which, so like, and in the actual bicycle class that she's spent this whole book writing, within the code there, you get all three. So bicycle, a mountain bike is, you could have an is-a relationship there with, if you decided to go classical inheritance, a mountain bike is a bicycle. With module inheritance, you have a bicycle behaves as a schedulable. A bicycle, it doesnn't make as much sense to say a bicycle is a schedulable. It's more like a bicycle behaves like a schedule, because a bicycle is kind of its own thing. Whereas it doesn't make sense to talk about a mountain bike outside of the context of a bike. It does make sense to talk about schedulable or bicycle or schedulable separate from one another. So you can say it behaves as a schedulable, but it isn't a schedulable. That makes sense to me. So that's actually where I've started noticing, like, oh, okay, this is where I might use module versus classical. And then the third one, the has is where we got into the parts object and the part object. The bike has a parts object, and the part objects have many part objects.
Right.
So yeah, that was a useful context. So she does a really good job of talking about like the benefits and weaknesses of each one.
Yeah, and she goes back to kind of the concepts. I think it was like either chapter 1 or chapter 2 where we talk about, I think it was chapter 1, we talk about code being true, transparent, reasonable, usable, and exemplary. So as she talks about inheritance, one of the benefits is that it excels at being reasonable, usable, and exemplary. So she kind of says this in the sense that it's reasonable because big changes in behavior can be achieved via small changes in code. So you really only, if you want something to scale, like trickle down, you can do that very easily.
That's also dangerous, though.
Yeah, which is also a cost of inheritance for sure. Right. And then having usable code. Hierarchies are usable. You can easily create new subclasses to accommodate new variants. And I think the cost of that was, you can. It also you might encounter a variant that doesn't quite fit the mold, and it could
Like we
not
did with
make
the
sense.
recumbent mountain bike.
Right. So then you have to rethink everything. But if you,
Right.
you know, if it's clear, then it might be good. The last one was exemplary. They're by nature they provide guidance for writing the code to extend them. And on the flip side of that, she says chaos that ensues when novice programmers attempt to extend incorrectly modeled hierarchies is a huge cost of inheritance. So she kind of sums this up, the costs and benefits of inheritance, by saying inheritance, therefore, is a place where the question, what will happen when I'm wrong, assumes special importance. Because inheritance is so, I mean, it places such an emphasis on being dependent on other classes.
Well, and she talks about how important it is early on in the book to decouple to have a code that is decoupled and independent as much as possible. And the whole idea behind inheritance is that you're working against that concept to some extent.
Yeah. Yeah. So, like you said earlier, in terms of inheritance, she points out enormous, broad-reaching changes in behavior can be achieved with very small changes in code, and obviously that can be amazing and very helpful, and also hugely destructive.
Right.
So I guess just be careful when using that.
Well, and I think that she comes to the same kind of conclusion that we did, that is if you're a new programmer, you probably shouldn't use inheritance unless it's like so obviously correct that it's just kind of smacking you in the face.
Right, right. Yeah, and going back to that inheritance chapter when, when she's like really just like don't do it until you have 3 subclasses where you can like abstract away the superclass like in a definite manner as opposed to just guessing. And yeah, I guess it's just approaching it with that in mind. So, and then she goes into talking about the costs and benefits of composition. And she also models this after the true.
I wanted to mention one thing.
Yeah.
She does talk about one more cost of inheritance, which is who else is going to be using your code. So how are you going to have a lot of people coming in behind you and refactoring or adding new classes and things like that to your existing code base? And if that's the case, sometimes inheritance can make your code harder for them to read. And so readability is super important for maintainability. And so she shows some workarounds for that in her inheritance chapters, but even then it can be important to, if you can avoid using inheritance, if you're going to have a whole bunch of people coming in behind you to look at the code base, it might be important to, it might not be worth the hassle for the maintainability concerns.
Yeah. Yeah. So I know coming at least from my standpoint, maybe it's just because I'm more familiar with the concept of inheritance, but I feel like even though that is more difficult to like hunt down a method within the Amazonian rainforest that inheritance could end up being, I feel like it's at least more of kind of a straight path, whereas I don't know, I guess because just composition is still relatively new to me.
The problem is when you don't even know that there's a method that you need to hunt down.
Right. Okay.
Does that make sense?
Yeah.
Because you can get, when you have inheritance, it's entirely possible to inherit methods, and unless you're being careful, you don't even know you're getting them. And then you make changes to a class that breaks something or overwrites something that you're inheriting, and it changes the entire, behavior of stuff down the road.
Yeah.
Yeah.
It's just something to be aware of. It's not a it's not a don't use inheritance. It's a this is something you need to be aware of.
Right.
Also, I think it's a good practice to whenever you're faced with having to choose inheritance over composition, always prefer composition. And when you're pressured on using inheritance, make sure that.
We lost you, Mo. Hello?
Yeah, that was a cliffhanger.
Yeah, we lost him. I think he cut out.
Oh no.
He'll be back. He dropped out for a little bit earlier. We'll just make sure he knows to keep that thought.
Yeah. Yeah. So
do you want to go on to the benefits of composition?
Why don't you take that? Because I did inheritance.
Yeah.
I'm sorry, I got disconnected for a second.
It's okay. Yeah. Go ahead. You were right in the middle of a good thought, and then we lost you, like all of a sudden.
So what I was saying, that if you're going to use inheritance, make sure that it's at the leaf level, so at the base level of your design, so nothing inherits from your inheriting class. Does it make sense?
Does it like try to keep the inheritance as low level as possible? Don't go way up the tree?
Yes.
Okay, that makes
so
sense.
Don't create a class and then inherit from that class and then again re-inherit in a subclass and then it goes on.
Yeah, I could see how that would break all kinds of. That would create all kinds of. It makes it impossible to keep all the code in your head.
Yes.
Yeah, that makes sense. Don't inherit more than one place on the tree.
Mm-hmm.
Yeah, that makes sense. Okay, so let's look at composition. The benefits of composition. You get many small objects that have straightforward responsibilities. That's good. You want single, they're accessible, clearly defined interfaces. They are transparent. Transparency is a good thing. It's easy to understand the code. Composed objects independence from the hierarchy means that it inherits very little code and is generally immune from suffering side effects as a result of changes to classes above it. And so we saw that with the recumbent bicycle thing. When she did composition, it just naturally resolved a problem. It just kind of dissolved away a problem that otherwise would have existed in like in the inheritance option. It's reasonable. Because composed objects deal with their parts via an interface, adding a new kind of a part is a simple matter of plugging in a new object that honors the interface. So, and well-composed objects are easily usable. By their very nature, objects that participate in composition are small, structurally independent, and have well-defined interfaces. This allows seamless transition into pluggable, interchangeable components. So yeah, those are all good. Like, this is how I learned. Like, I didn't know it was called composition, but this is how I learned to build code. Like always look for new classes to break out into.
Right.
If you have a collection of things, always be looking for a way to break that collection into like individual class, like components of that collection into an individual class of its own and that kind of stuff.
Yeah.
So there are some costs of composition, though I don't think they're nearly as big as the costs of inheritance. And you can tell based on how much she has to talk about the cost, because she dedicates over a page of her book to the cost of inheritance, and she dedicates
a paragraph,
a quarter, less than half a page to the cost of composition. So even if each part is small and easily understood, the combined operation of the whole may be less than obvious. So it's hard to keep the entire. So you talked about that a little bit, Mary, where you said it was hard because this was a newer one to you. It was harder for you to keep the whole thing in your head.
Yeah.
So that's a legitimate thing, legitimate criticism of composition. So while every individual may be transparent, the whole may not be. The benefits of structural independence are gained at the cost of automatic message delegation. So that's true. the parts object needs to know that it's getting parts, and it needs to know, like they kind of need to know a little bit more about each other. Identical delegation code may be needed by many different objects. Composition provides no way to share this code. I'm not sure what that means. Identical delegation code may be needed by many different objects. Oh, okay. Yeah, you may run into dry issues where you got different parts all having to repeat the same logic, or repeat the same, not logic, but well, it might be logic, but like if you have a parts list, just by its nature, a lot of the parts are going to look very similar to each other. A lot of the part objects or open structs or whatever are going to look very similar to one another, and so you may run into dry issues there if you go the composition route.
Mm-hmm.
So that makes sense. And composition is excellent at prescribing rules for assembling an object made of parts, but doesn't provide much help for the problem of arranging code for a collection of parts that are very nearly identical. So that makes, yeah, so exactly. Yeah, that's what we just said. Like,
right.
Composition can, if you're having to arrange them and start messing with a whole bunch of very identical, similarly identical things, you're gonna get very undry code if you use composition.
Mm-hmm.
So if you know, sorry, go ahead.
No, I was just gonna ask. So can you use like a combination of both inheritance and composition?
Sure.
Like, is that like best practice, or is that like?
So she would in this case. Like the bicycle is going to be, it's going to have the module. It's going to inherit the module schedulable.
Okay. Okay. So we're still using all of those things.
So that's one that it was. But then she also uses composition to break the bicycle class out into, the actual spares portion of it. It gets broken out through composition into a parts list, or into a parts object that has part objects, and that portion of the bicycle is going to be composition, but the schedulable portion is going to be inheritance.
So
okay.
I think answering your question is yes, you can mix and match between these three techniques of sharing logic through modules or inheritance or composition. The question would be, when would that scenario arise, and the answer would depend on your requirements at the time. So these are three techniques. She lays them out for you to use whenever you feel like this technique overwhelms the other.
Right.
Yeah, and I think one of the things to keep in mind is if you use classic inheritance and module inheritance, it gets really hard to keep track of what everything's doing pretty quickly.
Right. Because I was just thinking, like, so within this example that's up on screen right now with the config stuff, I mean, like, technically, like, you have no checks, as is, you have no checks in place to say that, like, tire size is even a number.
Right.
Well,
so she doesn't want you testing type. Remember? Like, that's one of the things we don't want to do is do type checking. We want our classes to trust that they're getting the right thing.
Okay. Yes. Right.
And then we would have, so in that kind of situation, you would have things like error handling. That if it didn't, when you call the method, if you didn't get the right kind of thing, then you would have error handling implemented in your code to deal with those kinds of problems.
Right. Yeah. I guess that's what I was looking for.
But that's not something that she covers in this book, or I don't think so. Anyway, that's a separate book.
Yeah. I guess I'm just thinking. So.
I can understand the confusion behind which technique should I use and when I should use that, because
Yeah.
in my simple mind at least, I tend to like to use one technique all the time.
Hmm.
It makes me feel better.
Which
Uh,
which
Yeah.
which do you have a preferred technique, or are you just saying in any given class you only like to use one?
I'm talking as humans, we tend to pick up
Nice.
one thing and just make it our favorite. For
Right.
example,
Right.
Ruby. We can say, "Oh, this is my best language, and this
Yeah,
is
yeah.
it does everything," and so on and so on. And this is also what makes this book really, really cool, is that she puts all these techniques in one simple example and make you face that example, so you understand what she's saying, but you're still confused. How can I apply this to my application? How can I
Right.
apply this to my situation?
Hmm.
But this never comes until years and years of writing code.
Well,
Right.
and one of the things she talks about very early on in the book is that writing code is about choosing the best of a bad of like you're not there's not a perfect solution. It's choosing
Absolutely,
the least bad solution.
Right.
absolutely.
Right. Yeah. Yeah. I mean, I guess it's just one of those things that you just have to do it enough until you kind of get the hang of it. Choosing which one. Uh,
But don't get discouraged, because I wish I had this book many years ago. Uh, so don't get discouraged. You will learn, and you will learn the hard way.
right. Like everybody else before me.
Because
at least you
yeah,
at least you've been exposed to the concepts. Like the fact that you even have access to the concepts now, and like you when you run into problems later, you can be like, this problem that I'm running into seems familiar for some
Right.
reason.
mm-hmm, mm-hmm.
Right. It's funny because like I'm taking I guess it's a non-traditional, but it's becoming more traditional approach to learning this in that I'm teaching myself, but I'm also approaching this very school-like in the sense that I'm reading a lot more theory than I am actually doing practice. And so it's like just another semester or whatever. But,
Yeah.
you know, but once, yeah, I just need to get down and just get into
I,
it.
I think for every computer or IT guy, there is a split personality within each and every one of us. We are part scientist, theory, and part engineer for
Mm-hmm.
perfection. What we're doing right now is engineering. We're trying to perfect our techniques and make our code better for many reasons: usability, maintainability, whatever the reason would be. And the science part would be actually writing or understanding how to write the code for the first time, like learning Ruby for the first time. That's the science part of it, because it's a totally new discovery
Mm-hmm.
to us.
Yeah. Yeah, and I'm definitely one of those people that I want to know everything there is to know about something before I start doing anything like big. So, but I know with this stuff it's like you have to do the hard things before you learn anything. Um, so, but that's where this book is helping because it actually has a lot. I feel like this chapter, the first half of it had a lot more code than words. Um, a
Which
lot
I
more
like, actually.
examples. Yeah, I really like that a lot. And you can kind of, and I do like how she also, quote unquote, runs the code and shows you what you would get, as opposed to just like spelling it out and being like, just trust that it works, which I've seen plenty of times too. So that is helpful. But so the last part of this book is about, or this chapter is about choosing the relationships. And Clayton, I think you touched on this earlier at the very when we started talking about this, like chapter 8b or whatever, second half of
Mm-hmm.
chapter 8, using the is a versus behaves like a,
And the has
versus the has a, yeah.
that was where, because remember we had talked about earlier, she drew a distinction between and a behaves like a in
Mm-hmm.
chapter 7, where she says like module inheritance is a behaves like a, and classical inheritance is an is a. And at the time we were like, okay, what's the importance of that? And then this is where that comes together as, this is why this is an important thing for you to keep an eye out for, because it kind of gives you a clue about which one you should use. And she gives an idea of like the context of how to tell the difference between the two.
Right.
And also then she goes on to the has a relationship, which is what composition is.
Right.
So in real life terms, I think a perfect example would be in Rails. For example, suppose you're creating a Rails application and you have a payment gateway where your customers can pay you. So you have a payment class, and underneath that you can use either inheritance or composition. Let's choose composition for the moment as an what was that? Kind of. Was it?
Is a.
Behaves
Is
like
a.
a?
Yeah, sorry.
Yeah, is a.
Yeah, is a. So you can compose from that payment class a PayPal payment or a credit card payment or whatever payment there is.
And they are all a payment.
Yes. And the module, which is what was that? Kind of.
Yeah, it was a behaves like.
Behaves like. So it's kind of an adjective like. It's like you have, for example, three views: a post controller, a photo controller, and something else, and they all share some logic. For example, you can comment on all of these. So it would make sense to create a commentable module, and that's an adjective. So instead of writing photo comment class and controller and then write the logic for that and then rewrite the logic again for a photo comment. So using modules makes the code more dry.
Mm-hmm.
I hope I'm making sense here.
Yeah,
no, that makes perfect sense. Yeah, commentable on something like that is a perfect example of where a module would be a good use, because those aren't going to have, it doesn't even make sense for them to inherit from like a comment class like above them, because they're not subclasses of anything.
Yes.
Right.
But it makes total sense for them to be for them to inherit from something that behaves, for them to inherit behavior, similar behavior. So yeah, that's perfect. And then the composition, it has, and if you do, when you start working in Rails, this makes total sense. Rails is built around, like the active record system has many relationships and stuff like that, and that analogy works really well here.
Yes.
Yeah, I remember that from the first Ruby Monday blog, actually. So that commentable explanation made a lot of sense because I've encountered that before.
Yeah, there's a lot of Rails that works that dovetails with this idea of composition, and so like Rails is the idea of the way Rails has relationships between tables on the database is very similar to the concept here of how classes can relate to one another, and I mean, which makes sense because, I mean, you actually say in your code in Rails, like, this has many or this has one.
Yes.
And so, yeah, that makes total sense to me.
Yeah. Yeah. I remember that coming up a lot, and now it makes more sense in context to how those all relate. So now we've come full circle back to the summary. So yeah, we talked about composition and classical inheritance, behavior sharing via modules, and how to choose which is best for what you're writing, and basically she sums it up by saying it's a matter of experience and judgment, and one of the best ways to gain experience is to learn from your mistakes. So I like how she presents this in almost in a way that, you know, I feel like this whole book basically has been building to it's just been one big refactor of the same code, which I really appreciate because, you know, you can see how you can do different things with the same stuff.
I actually, one day I went and read the Amazon reviews for this book, and one of the criticisms for the book was this book is just one big refactoring.
Right.
And everybody piled on and was like, yeah, that's the whole point.
Right.
you clearly didn't get the book.
Right. Yeah, because that's most of what writing code is, right? Is refactoring and making it better.
You know, it's learning, she teaches you the design concepts by writing it the bad way and then refactoring it to make it better. Like, that's the whole, like, the fact that somebody would criticize the book on those merits means they didn't even get the point of the book.
Right. Or they somehow write perfect code to begin with and think it's ridiculous that everybody else does. So,
exactly.
Which is like one person. So maybe it was that one person.
Yeah. They're the unicorn.
Right, they're the unicorn. They're the 1 in a billion that have it down. Good for them.
Yeah, exactly.
So yeah, so that was chapter 8. And chapter 9 looks to be a gigantic mammoth chapter.
Yeah.
It is. Quite huge.
Unfortunately, I think she's using mini-test in the last
really?
I think she wrote this before RSpec became popular.
Yeah.
She is using mini-test, which is, you know, makes sense. I think mini-test is the default for Rails. At the time she wrote this book, mini-test was pretty popular.
Yeah.
So it's 10 pages, 50 pages.
Yeah, I need to learn mini-test anyway, so this is my
excuse.
There you
go. That's a good excuse. So yeah, so this is going to be interesting because I am still very confused by testing. So that'll be exciting.
Testing makes you sleep well at night.
Yeah, it does.
Yeah.
Every once in a while, I'll have a moment where I'm like, I wonder if my website's working. And then I go run my test suite and click around on it a couple of times, and then I'm like, yep, still working, and then I go back.
Pretty funny. So, I guess that's something I should learn.
Getting that green line of dots makes you feel really good if you have pretty good test coverage.
Well, yeah, so I do the Code Wars stuff, you know, and to finish those you have to pass tests, and that is very satisfying when it runs like 100 things and it's like, you passed. And it's like, yes.
So I'm pretty sure that exorcism.io uses mini-tests for its test suite. So if you want to learn mini-tests, you should go play around with some of the quizzes on exorcism.io because it'll give you an idea of how mini-test works.
Cool.
Also, I think, because I used to face this a lot in learning anything. I used to go breadth and width and breadth and depth. So I try to learn as much as I can on many subjects, and at the same time I try to go as deep as I can in each subject. And that's really wrong. I mean, at the end, I ended up learning nothing. So my advice is take it easy on yourself. Try to learn the general concepts first. I'm certainly doing that. For example, if you end up this book and then you go on to testing, and then you, once you do testing, for example, a month or two, and then you go on to another subject, then you will feel that you're missing on some things that you've learned 2 or 3 months ago.
Yeah.
So
I wanted to say there's also a talk at RubyConf this year called a guided read of mini-tests. And I'm pretty sure it's part of the Less Code track because in the description he actually talks about how mini-test is actually only 1,500 lines of Ruby code. You get the entire mini-test system with 1,500 lines of code, whereas RSpec is nearly 15,000 lines of code.
Wow.
Yeah. So
That's a big difference.
yeah. So that's interesting to me, and I'm curious now why that's the case, and kind of want to go to that talk and see if there might be, because that seems to me like an advantage over RSpec if you ever need to go in and see what Minitest is doing exactly.
Actually, I think it's when you're talking about RSpec, you're not talking about RSpec alone. You're talking about RSpec mock, RSpec, and about 5 packages.
Yeah, there's Rails and Core and mock and whatever else. Yeah, there's like 5 of them now.
But the base Minitest is just a simple thing, and you keep extending it. For example, if you need to add mocks to Minitest, then you have to require the Minitest mock library. So I think that's somehow not, the comparison is not really accurate package per package.
Well, it makes me want to go to the talk and find out.
Yeah.
It's a clickbait.
Yeah. So I think we are close to done for the night.
Yeah. Yep. Yeah. Cool. Okay, well, I'm going to go ahead and stop broadcasting, but feel free to hang out. So everybody watching from the future, goodbye. We'll see you next week for our last book club.
The day before I leave for the conference.
Yay.
Yeah.
So exciting. So